So this is part 3 and the final part for systems thinking concepts. This part will include systems thinking types, system thinking as perspective, as a special language, and as a set of tools. First one is systems thinking types. So there are 7 of them. The first one is we call as closed loop thinking. So closed loop thinking we have covered before, right? So thinking in loop, where you have one action that will create effect and influence others' reaction. So the second one, we have generic thinking. So generic thinking is the ability to see the generic structure which occur in different settings. For example, let's say we have a model which tells us the production of a cow, right? So we can take the model and use it in a different situation. For example, like structural forces which influence the annual sale. So that is what we call as generic thinking. Is structural thinking. So structural thinking include stock and flow. So for example, let's say we have the production, we want to look into the structure of production of cow. So for that, we need to look starting from the flow of cows, which comes from birth through maturity into the milk cow accumulator. And then the annual milk production is then determined by the number of milk cows at one time and the amount of milk per cow. So structure also consider other factors, for example, like food supplies, the milk demand, and also the dairy farmers. So operational thinking helps in identifying the leverage point and also for effective communication. So let's say if you want to increase the milk production, you need to examine how milk is actually produced in terms of the numbers of cows and also milk per cow per year. So you need to look at the world and how things really work. So that is operational thinking. We have continuum thinking. So let's say you are trying to hire a worker. There's a opening for a position, right? So you have two types of candidate. The first candidate is a candidate with a very good academic background but with no working experience. And then you have another candidate with, let's say, 10 years working experience but graduated with a CGPA less than 3.0. So which candidate are you going to choose to fulfill the position? So this is involving the continuum thinking. Scientific thinking. So scientific thinking, making things quantifiable and also testable. Anything that involving scientific approach. We have algorithmic thinking. So it involves thinking algorithmically. So it is steps taken in order to solve up the problem. So normally a computational types of problem. Thinking can be used as a perspective. So this involves the closed loop thinking where every part of a system are connected either directly or indirectly. So let's look at the fluid balance in your body. Right, so let's say the fluid balance in your body is low. So when this is low, so you will have the sensation of thirst will increase. Okay, so you will feel very thirsty. Right, so when the sensation of thirst increase, so what will happen? So you will drink. Okay, drink a lot of water. When you drink a lot of water, what will happen to the fluid balance? It will increase. So when the fluid balance increase in your body, so what will happen to your sensation of thirst? Okay, so your sensation of thirst will decrease. So when this decrease, okay, what will happen to the drinking? So you will drink less. When you drink less, what will happen to the fluid balance in your body? Right, so it will decrease, which in turn will give you the sensation of thirst. Right, so you see this is in what we call as a loop. Right, so this is the example of thirst feedback loop. So it is a closed loop thinking. We look into a situation as a perspective. Can also act as a special language, which helps us to see events and patterns in our lives in a new light and respond them in a high leverage ways. Okay, for example, let's say we have a fire breaks out in the town. Okay, so the event. right? So if we respond by simply putting out the fire, so we are reacting to the situation. But if you also try to study where the fire tends to break out in the town, so you are looking into pattern, right? So as the result of looking into pattern, let's say you locate more fire station in those areas, so you are actually adapting to the situation, but you still haven't done anything in order to prevent the new fires, right? And then you try to look for a system, for example smoke detector or building materials which used influence the patterns of the neighborhood outbreaks. Okay, and then as the result of this, you build a new fire alarm system and establish fire and safety code. Then only you are creating change, so finally you are doing something to prevent the new fire. Why do we also call system thinking as a special language? Because basically it helps us in terms of communication, to communicate with other people about the system that we have in the surrounding, and it emphasizes wholes and also rather than part, and also in terms of the circular feedback. Okay, we also have special terminology which describe the system's behavior. So we have the reinforcing process, and we also have the balancing process. So these two will be described more in the next lecture. So systems thinking can also be used as a tool. So it have generated a lot of tools that can be used in the system thinking field, right? So the function of these tools is basically to graphically depict the understanding, okay, and for communication purposes, and for designing the high leverage intervention, especially for problematic system behavior. So the tools, there are the few tools that has been created. For example, we have causal loop diagram, so we have behavior over time graph, we have stock and flow diagram, and we also have systems archetypes. So these tools will be covered in our next lecture. So that's all for this lecture. So we have covered the systems thinking in terms of the mental process, in terms of the principles, the dimension, types, system thinking as a perspective, as a language, and as a tool.